Hello and welcome to our final project presentation for ECE 3710. I'm Jaxon Lofthouse.
And I'm Sage Mathews.
Overall, our goal for the project was to create a radio-controlled, or Bluetooth-controlled in this case, remote-controlled car. We were going to do this with transceivers and 2 microcontrollers along with some switches to control the direction of the wheels in a skid-style movement, so that we just had 2 motors and no steering. It would just drag the front wheels to turn. We were able to get pretty far with this, but we did not complete all the goals, as we will talk about.
One of the major difficulties we had was interfacing with our transceivers using SPI. We actually moved from transceivers to a wired interface because we were not able to address our transceivers with this SPI interface.
We spent several days working with the SPI to transceiver interface, and we found that no matter the pinout we chose or the implementation of SPI, we could not get our microcontroller to communicate with the chosen transceiver, which was the RFM69HCW by SparkFun Electronics. We were struggling to get the microcontrollers to talk to them, and also the 2 transceivers to talk to each other. But we decided to move to a wired system so that we could create a car and implement the rest of the project and move forward.
So this wired connection would be just 1 microcontroller instead of 2 talking to each other. This microcontroller would talk directly to these motors that we have on the RC car using 6 GPIO pins and long extension cable.
So to do this, we're going to use an H bridge, which is implemented here on the breadboard. And using the 2 H bridges essentially creates 2 motor drivers. And those motor drivers are powered by 9-volt batteries with voltage regulators to step the voltage down to the required amount. And then the remote will also have another 9-volt battery and it to power the remote separately.
So with these new goals in mind, we will move into a demonstration of the progress that we actually made on the project.
We will begin this demonstration by showing how the vehicle works and how it can move, and then also we will show how the remote works and its associated functions and the progress made on that front as well. Okay, so for our vehicle here, you can see we fabricated out of some Legos and some DC motors. We also used the H bridge along with 9-volt batteries to power the vehicle. So when we turn it on here, we can see that the motors for both the left and right sides do spin. And then as we power them up here, we can set it on the ground and let it drive along. It is a little slow and does not have very much power, and that comes down to our DC motor selection. When we were selecting the DC motors, we did not take into account the proper amount of torque that is going to be required to move it. The vehicle does move, but as you can see here again, set it on the ground and it drives, but it's not the quickest or the most nimble vehicle out there. And then we'll go on to the demonstration of the remote next.
All right, so this is our remote. We have it connected to our computer right now so we can see what's going on in our system viewer on Kyle. And here is our code. If I just show you these, where is my mouse? There it is. If I show you these system viewer ODR pins, if I push up, 1 and 4 turn on. If I push down, 2 and 4 turn on. If I push up on the right side, 0 and 5 turn on. If I push down on the right side, 3 and 5 turn on. And I can push any combination of these and get multiple pins turning on at the same time. And these outputs control the motor using the H-bridge.
So using this wired connection we have here, that contains those 4 pins, then a ground pin to ground the microcontroller to the car. We have it connected here, and it drives. We can drive that motor there and show how it all works. And we will add a connection right here, and we're powering it with the power supply in the lab, so that our batteries, they're all dead. So we're powering it with the power supply to show you here. So when we push up on the switch over there, and then we show, the wheel starts to turn, and then we shut off the switch, and the wheels stop. And overall, it connects to the remote, and sometimes it does some weird stuff, but it does not. The main problem with it is that because of if you push up on the switch there while it's connected, because of the low torque motors, it does not move on its own. If you give it a slight nudge, it will start to move, or if you lift it up, the tires start to move, as shown here. The main issue that we have is the low torque motors just cannot move the weight of the vehicle.
So in conclusion, we're at a point where all of our parts of our project work independently, but we've yet to reach a point where we can bring them all together and make them work as one solidified thing.
So when testing on the bench, the remote shows that it works and is commanding the correct pins to send the correct commands to the car, and the motors independently work using battery voltage and power supply voltage. And when we connect them and we lift them into the air, we can get the motors to turn. But our main issue is being that the motors that we have don't have the torque required to move the vehicle under its own weight. So when we set it on the ground or try to test it in a more real world scenario, the car doesn't move. And that could be fixed with a couple deals. We can make the motors bigger and get a little bit more powerful battery, and that would help. And then also some gear reduction or other mechanical advantage built into the driveline would also aid quite a bit in making the lesser powerful motors work. But overall, the project went pretty well. We were not able to get a fully complete finished project just because of some limitations we had with hardware. But through our modified goals, we feel that we have achieved most of them, with the exception of getting the whole system to actually physically move on its own power on the ground, due to the limited power of the motors and the connection issues we were having with the transceivers. Overall, we feel like we learned a lot, and this is the conclusion of our microcontroller's final project.